Okay, so as a follow-up video of the formal charge video which I did recently, I'd like to describe some applications of formal charge, specifically in terms or in the context of organic chemistry. So recall please that in organic chemistry, the primary portion of our life is right here. Boom, 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 right? In other words, we care about hydrogen, carbon, nitrogen, and oxygen. And yes, it's true that we care about some halogens too, right? So, and definitely there's some other elements that creep into organic chemistry, but this is really where our world exists, and I'm going to include halogens in this. So 5 things. So what this means is, let's look at some examples which we looked at before for formal charge here. The formal charge of hydrogen here in this compound is the valence number, which is 1, minus all of the shared, or rather half of the shared, which is 2, and all of the unshared, which is 0, right? And if you do that a bunch of times, you pretty much come to expect that hydrogen's going to have 1 bond and no lone pairs of electrons. I'm going to make up some notation here. Bonds, lone pairs. Okay, 1 bond and no lone pairs. Okay? And if we do this with carbon a bunch of times, we're going to find out that carbon has a tendency to have 1 bond. Let's do this. Let's put carbon here, nitrogen, oxygen, and fluorine. Okay, and we'll see. The carbon has a tendency to have 4 bonds and 0 lone pairs of electrons. And I'm just making up this notation because I want to, right? Bonds and lone pairs. Okay? Because I want you to see the trend. Nitrogen has a tendency to have 3 bonds and 1 lone pair of electrons. Oxygen has a tendency to have 2 bonds and 2 lone pairs of electrons. Halogens have a tendency to have 1 bond and 3 lone pairs of electrons. And of course the noble gases, which we never talk about, have a tendency to have 0 bonds, right? So 4, 3, 2, 1, 0 bonds. And 0, 1, 2, 3 lone pairs of electrons, and generally 4 lone pairs of electrons for those guys. Alright, so that's if the formal charge is 0. Here's what you need to be ready to recognize. That if carbon has 3 bonds and 1 lone pair of electrons, it really went from it having a shared pair over here to an unshared pair over here, which sort of changes its location over here. That really means it's going to have an extra electron. Okay? That's going to have a formal charge of -1. If carbon's got the electrons that are gone, completely gone, this is going to have a formal charge of +1. Alright, so here's your application number 1. That carbon is going to be 0 if it has this, -1 if it's got that, +1 if it's got that. And we're going to find that the same rule applies for all the other ones, that if you take away a bond completely, it's going to go up 1. If you take an atom away and give it a lone pair instead, it's going to go down 1. So oxygen wants to have 2 bonds and 2 lone pairs of electrons. If something takes away one of those, if it gets an additional bond, that's going to have a plus on it. And if oxygen gets an extra lone pair of electrons and loses a bond, it's going to have a minus on it. Right? And we're going to do this so many times that we eventually get to the point where we simply recognize it. Nitrogen has a tendency to be like this, which is neutral. That's going to be plus. That's going to be minus. Okay? And these are the 3 big ones. Carbon, oxygen, and nitrogen. Those are the 3 that you're going to see over and over and over again. You'll eventually accidentally memorize that. You'll just recognize it by sight. But I do encourage you to take some time in the beginning of your training in organic chemistry to really think about why that's the case, and it all boils down to this formula here.